So they've given us the objective function, and they've given us the constraints. So all we have to do is find the minimum and the maximum values. But as you recall from all of the problems that we've done up to this point, you cannot find minimum and maximum values unless you have the vertices. So we're going to have to come up with the vertices. Well, let me just jot this objective function down, p equals 7x plus 8y, because that's what we're going to use once we have the vertices. That's what we're going to use to figure out what our maximum and minimum values are. To start with, I think we should get this in slope-intercept form, and we should get this in slope-intercept form, so that we can figure out what the vertices are. All right, so I'm going to start with this one, and we've got 3y is less than or equal to, notice I'm just bringing the negative 2x over right away, plus 100. Getting y by itself, we have y is less than or equal to negative 2/3 x plus 100 over 3, which is going to be 33 1/3. Okay, well that wasn't too hard. Let's go to the next one, which is going to be 5y is greater than or equal to, I'm just bringing the 4x over right away. I've got negative 4x plus 75. So that means if I divide everything by 5, I get y is greater than or equal to negative 4/5 x plus 75 divided by 5 is, I know this, 15 in my head. Thank you very much. And so now we have, well, we have our two equations. We've got x is greater than or equal to 0, y is greater than or equal to 0. So we're pretty much good to go, but we have to get a visual on this. Okay, so I'm recommending that you just plug these values into your calculator rather than actually taking time to graph them. It's up to you. You can do either one. I will tell you, though, that once you've got them in your calculator, we really don't care about anything except the first quadrant, right? So I'm just going to draw this over here with the first quadrant, this negative 2/3 x plus 33 1/3. Just a rough sketch here, but I'm going to put 33 1/3 up here. And so if we go down 2 over 3, down 2 over 3, we've got this kind of thing going on here, okay? And then for this one, positive 15, we've got it coming way over here, all right? And that is negative 4/5, so down 4 over 5, right? So either way, we're gonna have something, you know, kind of like this going on. We need this. This one is going to be shaded below the line. This one is going to be shaded above the line, right? Because this is less than, and this one's less than, this one's greater than. Okay, so either way, the shading is going to go right in here somewhere. So what we're going to have is our feasible region. Now, you've got it in your calculator. Don't make this harder than it is. If you have it in your calculator, it's just going to make a lot more sense to you, I think. Okay, so we know this vertex and this vertex is, well, one of them is 0, 33 1/3. The other one is 0, 15. You can tell that from right there. That's easy, okay? The other two are going to be the places, and this is going off my chart here, but the other two are going to be the y-intercepts. I'm sorry, the x-intercepts. Yeah, this one here is off the charts here, but it's the x-intercept, okay? So to calculate the x-intercept, you can use your calculator, the left bound and the right bound thing, or you can do what I did, and that is just plug a 0 into the y location, plug a 0 in for the y, and solve for x. Plug a 0 in for the y, solve for x. If you do that, you end up, well, let's do this bottom one here first. We have 0 is less than or equal to negative 4/5 x plus 15. Bring that 15 over here, we get negative 15 is less than or equal to negative 4/5 x. So basically what you're going to do is take negative 15 divided by 4/5 x, and then do the same thing over here. You're going to get 0 is less than or equal to negative 2/3 x plus 33 1/3. bring this 33 over here, you're going to get negative 33 and 1/3 is less than or equal to negative 2/3 x, okay? So when you solve for x on both of those, you're going to be left with 18.75 is going to be one of the x-intercepts, and of course 0. And the other one is 50 and 0, okay? So now what you need to do is you need to plug these x, y values into your objective function, okay? So then once you plug all of these values, you should get some p-value for each of these, okay? So there should be you should have 4 different values, and it's just, if you do the math correctly, it's just simply now a matter of looking for the minimum and the maximum values, and whatever they are, that's what you're gonna write down. And guess what? I'm not giving you the answer on this one because I've done all of the heavy lifting, so you can figure out what the rest is from here.